Hi, in this video, we're going to talk about MRO in multiple inheritance. Now, a disclaimer here is that the algorithm we're going to describe is used in a rather old version of Python 2.2, but it's still worth studying for the reasons that I will explain at a later time. As a motivation for this topic, now remember this is the diamond of death problem that we briefly described in our study of multiple inheritance. And all of these classes define a full method that each of them just print out the class that the full method is in, and then it just calls the super dot full. And when we, well, except the class A, which is at the top of the hierarchy, so it doesn't do any super full call. Now, when we instantiate an instance of D that is at the bottom of the inheritance hierarchy and we call the full method, and well, I actually did do that here. And when we run the code, it prints out that the order in which the fulls method is called is DBCA. And if you come back here, it basically goes D, B, C, and A. And so something's rather weird here. For example, like B, when B's full calls silver.full, it actually goes to C's full. So how in the world did that happen? I mean, this was certainly a surprise to myself when I first saw this. So at the end of this video, we will come to understand why. So let's get to it. Now, multiple inheritance in its very simplest form is that a single class would inherit from at least two base class or parent classes. Right? Now, so in this case, then what is the MRO for D with two base classes, B and C? Now, we actually did deal with this problem before in our logic gate assignment that, for example, the unary gate can inherit from both the logic gate and the cost mixing. Now, at the time, I advised that in order to call the parents or the base classes than the init method, we will explicitly dereference the class, the base class itself. So we explicitly say logic gate dot done the init and cost mixing dot done the init. Now, some of you actually did it in a slightly different way, that you would do super done the init and then cost mixing done the init, and the super done the init in this case actually did call the logic gates done the init method. So when you and that works fine. So when you think about this and then look at this picture here, then you can kind of come to the conclusion that the Python actually searches the parents that are at the same level from left to right, right? Because super done the init actually calls the logic gates done the init. That conclusion would actually be correct, that the MRO not only goes from the derived class to the base class from kind of bottom to top, it actually also goes from left to right. So the MRO for D would be D, B, and C. So we can actually print that out to verify it. And what Python prints out is D, B, and C. And finally, yes, object. Let's not forget about that. Next, let's make things a little more interesting by adding a parent A to class B. So in this case, the question then would be when D, the MRO for D, would it be D, B, A, and then C? So in other words, it goes from top to bottom first before it goes left to right, or it goes from D, B, C, and then A, or in other words, it goes from left to right first before it goes all the way to the top. So we can ask Python to show us what it does. And let's run this. And the MRO it prints out for D is that D, B, A, C, and object. So it is D, B, A, C. So it goes from bottom to top all the way first, so depth first, and then it goes from, it backtracks down back to D and then goes to C. So this is what's called a classic MRO behavior, or if you want to know when it exists and which Python version it exists before Python 2.2. So this is pretty old. Now, finally, let's complete our diamond. So in this case, then what should the MRO for D be? Now, if it is, follow what we said earlier, that it is a depth first and then left to right, then what it should do is we'll start at D and then we go up to the left to B and then A. And when we reach the top, we backtrack down to D and take a different branch. Then we go up to C and then A. So we'll end up with a MRO that is D, B, A, and then C, A. Now, when you think about this though, there's something not quite right with this, and mostly because it searches A before it searches C. However, because C is a more immediate parent of D than A is, then C is really far more likely than A to have what D wants, right? And probably C would actually depend on something that's in A. So it's really undesirable to search A before it searches C. We really should do it the other way around. Searches C first before it searches A. Okay, so we have some difficulties here. Then what about we just avoid the diamond problem altogether, like what we said when we first studied multiple inheritance? Now, as much as we like to do that, it is actually not possible. Starting in Python 2.2 and then all the versions after that. And the reason for that is, even though B and C here, they don't explicitly inherit from any class, they do, as we know, implicitly inherit from the object class. So object is always there, therefore the diamond problem is always there. So Python 2.2 actually has a new algorithm for MRO. Well, it is actually the same old algorithm with a twist at the end. So let's see how it works. So we're trying to figure out, let's say, the MRO for class D here. So we'll start with D, right? And then it goes up just like before on the leftmost branch. And so we get to B, and then we keep going up. So B and A, and then O. And now we are done going up on this left side of D. Then we backtrack back to the first place where there is a branch. So we're back to D, because D has a branch here, right, going to the right. So the next thing we do is, now we take the other branch from D, we go to C now, and then we'll keep doing the same thing, keep going up this side of the hierarchy. So we'll go to A, and then finally O. Now, so far, this is very similar to what we did before, except now we have also object at the top, right? Now, the next step that this new algorithm takes is that it removes any duplicate except the last one. So what are the duplicates here? Well, there is there are two A's, right? So we'll remove that, and then there are two O's, and we'll remove that. So we remove between the two A's, we remove the first one, and we leave the last one. So if there are multiple A's, we'll always remove all of them except the very last one. And also, we remove the first O and leave the last O. And so we are left with the MRO of D, B, C, A, and O. And we can verify this by asking Python. So in this hierarchy, the MRO for D is D, B, C, A, and finally object, which is exactly what we derived here. Now, before I show the MRO of class D in action, I would like to point out one perhaps obvious fact, and that is we just derived the MRO for class D, but the other classes in this inheritance hierarchy, A, B, and C, they all have their own MRO. Okay, and their MRO are not the same as that of D, obviously, right? So to demonstrate that, I've defined a full method for each of these classes except for C, and I instantiate each an instance for each of these classes and call the full method on them. And this is the result of running them, which I copy and pasted here. So let's look at, say, A and B. Obviously, they define their own full method, and it doesn't call anyone else's full method. So then the output, as we expect, is A is full, calls full in A, B is full, call full in B. Now, C is slightly more interesting because it doesn't have its own full method, and we can see that from C, for class C, its MRO is basically just C and then A and then object, right? So when we call C full, it looks in C first. It doesn't find a full, then it looks in A, finds a full, then it calls A's full, and that's why when we say instance of C dot full, it calls the full in A. Now, with this out of the way, we can look at then what happens when all of these classes define a full method and all of their full methods call a super.full method except A. And when we instantiate an instance of D that is at the bottom of the hierarchy and call its full methods, then which full methods does each one of these call? So as I ran this at the beginning of the video already, I'm not going to run it again, but let's step through this D.full method call and see how the MRO of DBCA determines which full method actually gets called. So when we instantiate an instance of D and tries to call the full method in D, then it looks into the MRO for D. Well, the first one in MRO is the class D. Then it looks in class D and finds the full method. So it calls the full method and it prints out full in D. Okay, and next we call super.full here. Now, when we call super, then it looks in the MRO again and it sees the next one after D is B. So it will look into B and see if there is a full method. So there is a full method. So it prints out full in B. And then and before we go on, I just want to point out, going from D to B is going from a child to a parent or a derived class to a base class. Now, next, it calls super.full again. So super here, it would look inside the MRO and see after B, it is C. So it would look inside C and see if there's a full method there. Well, there is. So that's how it prints out full in B. Now, the interesting thing I want to point out here is that going from B to C is no longer going from a child to a parent or a derived class to a base class. It's actually going from a sibling to another sibling. So super doesn't necessarily go from child to parent anymore. All right, anyway, so inside C4, it calls super.full again. And the next one in the MRO would be A, so it looks inside A and finds the full method. So that's how we finally get to full in A. So I hope this explains what we saw at the beginning of the video, that why doing the chain full calls in this inheritance hierarchy would go from D to B to C to A. Now, there is a little bit of magic inside super that we haven't talked about, and we'll do so in another video. Now that we understand and actually kind of resolve the diamond problem, I think it's worth taking a step back and review what makes it such a big problem in the first place. Now, so the diamond problem actually have two little problems. The first one has to do with the top half of the diamond, that since both the B dot full and C dot full, they both call super dot full, then and super, as we previously understood it, both refer to the class A, then does it mean that we are going to call A dot full twice? And that's probably undesirable, right? And the second problem is that it's the bottom half of the diamond, that because D inherits from both B and C, and D dot full calls just a single super dot full, right? So which one of the B dot full and C dot full should this one call, right? That was another kind of little problem or dilemma. Now, the MRO of D, B, C, and A actually very elegantly, in my opinion, answers both questions. That the first question is, well, do we call A dot full twice? No, we don't, because A only appears in the MRO once. And the second question is, well, which of B and C's full do we call first? Well, we call B dot full first, but we also call C dot full. So constructing the MRO the way we did and using it to resolve which full method to call provides a satisfactory answer to both questions and make everybody happy.